For the given matrices, first off, can we add or subtract them? Because they both have the same dimension of 2 by 3. Yep. We'll do part A, I'll have you do B, and then I have to announce some theory, and then we'll do C and D. So for A plus B, if you add a 2 by 3 to another 2 by 3, it makes unbelievably, a 2 by 3. So just add corresponding entries. What's 2 plus 4? What's 3 plus 3? Negative 1 and 4. Keep going. Yep. Scale of 1 to 10, where 10 is the worst thing you've ever done in your life. 1, where is this at? 7 it is. So notice it just repeated, in this case, addition. That's it. Do students make mistakes? Yes, please be careful, especially when you have subtractions. If you would, to subtract matrices, just subtract corresponding entries, assuming they have the same dimension. What do you get? Negative 2. Negative 5. 12. Negative 8. 4. That's it. So for part C here, we're going to find 3A. So what that says is multiply all the entries of A by 3. What would you get? 6. That's it. Multiply all the entries by 3. And then in part D, we call that a linear combination. When you multiply one or both by numbers and add them together, or subtract in this case. Now to do part D, notice we already did the first part. We found 3A. Instead of multiplying B by 2 and subtracting, I would prefer you thought of this as 3A plus a negative 2B. Reason being is, as we saw, some people made errors in part B. Adding is easier than subtracting. So if you would, I would suggest first finding negative 2B and then adding that to your result to part C. So I'll have to decide what is negative 2B. Negative 8, negative 6, negative 8, 14, negative 16, negative 4. So taking those 6 entries and adding them to 3A, well, 3A adding to those, because we didn't talk about a property yet. What do you get? Negative 2, 3, negative 11. Yep. Very good.